Let's work on this example 1.20. In this example, I'm not going to show us how to algebraically solve for a limit if we get an indeterminate form. I just want to give two examples of graphs which have an indeterminate form of 0 divided by 0, one in which the limit does exist and the other where the limit does not exist. So let's look at the example where the limit does exist over here. All right, this function here, again, we're not going to solve it algebraically, but if you were to graph this, you end up with just a straight line, but with a removable discontinuity because this function does not exist at the x value of -1, right? If you tried to look at x is equal to -1, you would be dividing by 0. That's not allowed. So it's a removable discontinuity if you remember your study of algebra when you talked about rational functions. That's why we have this open circle at the x value of -1. But if we took the limit and we looked at the limit as x approaches -1, because that's the only possible place where the limit might not exist, right? This function is perfectly continuous everywhere else. If we took this limit and we just use our direct substitution method, then -1 squared minus a 1 over a -1 plus a 1 is going to give us a 1 minus 1 over a -1 plus 1. That is the indeterminate form 0 over 0, but the limit can still exist. And we're going to see that it still exists through algebraic simplification by factoring that numerator. Let's look at the other function, which gives us the same indeterminate form, 0 over 0, but here the limit does not exist. If we attempted to take the limit, again, this function is perfectly fine everywhere except when x is equal to -1. So this is the only interesting part of the graph. If we attempted to take the limit via direct substitution, then we would get absolute value of -1 plus 1 over -1 plus 1. -1 plus 1 is 0. Absolute value of 0 is 0. -1 plus 1 is 0. So here we also get the indeterminate form of 0 divided by 0, but the graph of this function has a limit that does not exist. So the conclusion here is, if you have an indeterminate form of 0 over 0, it's unknown whether the limit will exist or not. It's possible that it does exist. It's possible that it does not exist.